Hello there. I, Vanshika Tripathi, welcomes you to my ELP101 project video. Have you ever wondered how can lights turn on or off when we open or close the door of a washroom having automatic light system? Well, if you have, and if you haven't got a right answer or satisfactory answer, I would like to answer that question with all the research that I've done for my project. Coming to the introduction for my project, the circuit explanation that I have taken up is switching on or off of the light as we enter or leave the washroom through the door. What exactly might be acting as a finger to switch the lights on or off the washroom as we open or close the door? I would like you to ponder over that question for some time and then eventually I'll answer that. Now we come to the circuit diagram for the automatic washroom lights, and to that I would like to add a very delineating quote by Murray Walker which says, "The circuits are interesting as it has inclines and declines, not just up but down as well." And here is the circuit diagram for the automatic washroom lights. We have the switch, we have a potential divider system, we have an op-amp, we have another potential divider system, two capacitors, timer, and obviously the lamp that is to be lighted. But here I would like to tell you that this switch won't be turned on or off with our fingers touch. Rather, we have a different mechanism that I'll come to eventually. Now, more about the circuit components that we are using. We need 7 resistors of the following values of resistances: R1 being 70 kilo ohms, R2 of 10 kilo ohms, R3 of 50 kilo ohms, R4 of 22 kilo ohms, R5, R6 and R7 each of 10 kilo ohms. We need 2 capacitors of 470 microfarad and one of 0.01 microfarad. We need an op-amp, which in our case is LM741. We need a timer, which here is IC555, and obviously a light of 12 volt that is to be lighted. Now let me give you a brief introduction of the op-amp that we are using. In our setup, pin 2 and pin 3 are the input terminals, where pin 3 is the non-inverting input terminal and pin 2 is the inverting input terminal. A fixed potential through the potential divider system consisting of the resistors R1, R2, R3, R4 is given to the pin 3, and an input voltage through a switch is given to the input pin 2. Now let me give you a little information about the timer. It has 8 pins along with an NPN transistor, 2 op-amps and a flip-flop arrangement. Pin 1 is grounded, pin 2 is the trigger pin. The negative pulse on this pin sets the internal flip-flop when the voltage drops below 1/3 volt, causing the output to switch from a low to a high state. Then we have pin 3, which is an output pin 4, which is the reset pin 5 is the voltage control pin 6 being threshold pin 7 being discharge pin, and pin 8 being supply pin. Now let us come to the main part, that is the working of the circuit. Let me first answer the question that I asked you earlier, that what acts as a finger when we are not even touching the switch? The answer is apparently the door. The switch is placed in such a manner that when we open the door, the switch gets in on position. As we understand, op-amps are operational amplifiers and can perform functions similar to mathematical operation. And here, our op-amp is acting as a comparator to compare the input voltage at pin 2 and pin 3, that is at inverting pin and non-inverting pin. As we can see from the circuit diagram that when the switch is in open position, the inverting input terminal gets a voltage of 12 volts and the non-inverting pin, that is pin 3, gets a potential of across 4 volts through the potential divider system. Since inverting terminal has higher voltage input and a logic pulse sets up the timer along with the potential divider system of resistors comprising of R5, R6, R7. Timer is triggered when it receives that low logic pulse through the potential divider, generating a high logic pulse at its output pin, which is the output pin 3, and hence the lamp lights up. Likewise, when a person comes out of the washroom and closes the door, the switch offs. At this open switch position, the non-inverting pin of op-amp receives higher voltage as compared to the inverting pin. Thus, op-amp, acting as a comparator, produces a high logic pulse which fails to trigger the timer and also fails to lighten up the lamp. Now, here's the bibliography, that is all the references of the different websites that I have taken for my project. And at last but not the least, I would like to thank you for sparing your time and giving heed to what I said.